Hi, it's Andrew Kilpatrick here, and I'd like to tell you a little bit about the modular synthesizer that I've been building since about October of 2009. I decided to build a modular synthesizer to learn more about sound synthesis and to be able to keep experimenting with circuits that I might use in other projects. A modular synthesizer is a great platform for experimentation because each module is simple enough that you can build it in a short amount of time and see how it interacts with the rest of your system. If you don't like a module, it's okay, you can just change it or not use it. If you like a module a lot, you can build another one and have two or more. Some of my goals for this system were to make the system out of easily obtainable materials. Another goal was to use all my own designs for the system. And the last goal was to make the system in a way that I could build new modules easily without having to buy a lot of expensive parts or do anything that would take a long time. Probably one of the most important parts of any project is the power supply. So, of course, that's the first thing that I made for my modular synthesizer, other than the cabinet itself. The power supply is plus and minus 15 volts and plus 5 volts. Currently it's a linear supply with a transformer and linear regulators. In a future cabinet, I think I would use a switching power supply because I'm running out of power output on this one. Next, I designed a 4-channel mixer. Each channel has a line input, a pan pot, volume control, and a signal indicator that shows whether there's anything active on that channel. There's a master volume at the bottom, and stereo outputs come out and go to the output stages. The third module that I made is a MIDI to CV converter. As I was designing my first oscillator, I realized that I needed a very stable source of voltage in order to test the tuning circuit. This MIDI to CV converter has a MIDI input, and it makes 2 CV outputs. It also has an internal clock generator for advancing a step sequencer, and it can also lock to MIDI clock sync. There's various modes, including a split keyboard mode, 2-channel MIDI mode, unison mode, which is useful if you want to drive 2 oscillators off the same MIDI input, has a tuning mode as well, in which you can use the clock speed control to adjust the tuning. The fourth module that I built is a monolithic VCO using the XR2206 voltage-controlled oscillator chip. I've built 2 of these oscillators, and this oscillator produces sine, triangle, ramp waves, a sort of weird sine ramp, as well as pulse width modulation. So there's the triangle wave, sine wave, ramp wave, sine ramp, and the pulse width modulator. And I'm actually modulating it off the second oscillator. The oscillator also supports FM and sync inputs, as well as the PWM input, which you just heard. Next, I'd like to tell you about the quad VCA and the dual ADSR. These kind of go together, so I thought I'd demonstrate them at once. The quad VCA uses the SSM2164 VCA chip, and it takes 0 to 5 volts, which goes from totally muted to full signal. It also allows you to gang the control voltages for different channels together in different combinations. And this is useful because it saves having to have splitter cables and all that sort of thing. The ADSR is a dual ADSR. It has attack, sustain, decay, and release controls, as well as LEDs that show which stage you're in. These each use a PIC 16F690 microcontroller, which is kind of cheating, I guess, except I found it much easier to get the kind of response I wanted on each of the pots than building an analog circuit. And let me give you a sense of how it sounds. So the seventh module that I made is a headphone amplifier. This is a dual amplifier with two separate volume controls and two complete power amplifier stages, one for each headphone. The signal loops through the bottom, and it doesn't actually get rebuffered at all. There's a high impedance amplifier that extracts the signal from each channel. The next module I made is a digital effects processor. And this is actually based on a system that I designed for guitar players. It uses the same mainboard. There's a reverb effect and a delay effect in the same DSP. The reverb has a mix control. The delay has a mix control and a delay time control up to half a second. There's 2 reverb algorithms and 3 delay algorithms to choose from. This voltage-controlled filter is modeled after a similar styled filter used in a Russian synthesizer called the Polyvox. It has a very interesting characteristic in that it doesn't use any capacitors in the filter section. Now I'm going to leave you with some of the more experimental sounds using FM between the 2 oscillators.